You now hopefully see my slide in slide mode. Yes, okay, great. Okay, so I will walk through some of the sort of principles and concepts that we have around linked art. I'll just move the chat to my other window. And yes, as Emmanuel said, I'm Rob Sanderson, Director for Cultural Heritage Metadata at Yale, previously at the Getty. So there's some terms that we have used, which might bear a little bit of explaining first before we get into things, such as model or ontology or vocabulary and profile. What are all these things, and where does linked art fit into this ecosystem of standards and profiles? So the model that we use is the CIDOC CRM, which gives us an abstract way to think about the world, and indeed has an RDF ontology, which is a shared format that allows us to write down that thinking in a particular way. One of the great benefits of the CRM approach is the core integration with vocabularies, which enables us to, within a very controlled methodology, extend and define the sorts of things that we're talking about. So for linked art, that is primarily artwork, but also we're looking at how non-artwork related museum content could also be integrated, perhaps at a reduced degree of functionality. So the vocabularies then give us a domain-specific set of terms, and we use Getty AAT as the primary vocabulary for that. So then linked art is a selection of aspects of the model, aspects of the ontologies, aspects of the vocabularies, and formats for describing artworks and the entities, events, and systems that interact with it. So the conceptual model, as Emmanuel had, is one of events, where events or activities are in the center. They are about or they affect physical or information objects. So either things that you can, to use Stephen's example from the previous CRM workshop, through a window, or information objects that come from the product of human mental activity. These occur in time. They can occur in different methodologies. They have different techniques, which are types. They are performed by actors, be they groups or people, and they occur at locations. We then further refine this as part of both the CRM and linked art to be more appropriate to the domains. So one of the principles that we have in linked art is that of progressive enhancement. So we know that not every institution can instantly start off with producing perfectly accurate, semantically rich, and standards compliant data within a certain amount of time. So instead, we are looking for a methodology that allows us to improve over time, but still participate right from the very beginning. So we have four different sort of layers of accuracy. The first is legacy records, where there aren't really entities, but there are just descriptions. So these are strings that are hard to interact with as a machine. They're hard to link to. It's just, here is something that if you put on a screen, a human would understand, but there is no way for they're not data. They're only text. So then comes data for humans, which is to split up those descriptions into the core CRM entities that we've just looked at, and then attach the descriptions of those entities to them, along with some basic properties. Then we look at data for machines, where we can link the entities together with more machine-readable values and machine-comparable or processable values. And then data for research, which is the same, but with sufficient precision and sufficient amounts of data that we can answer research questions by pulling together information from different institutions. So linked open data should be easy to use, you would hope, but by who? So one of the initial approaches was, well, it should be easy to use by humans, such as researchers. So the data comes into the machine, essentially turning money into triples, and then it goes over magically to the researcher. But instead, we think that there is an intermediary, which is the software developer. So someone has to build something that uses that data. So this is where we get that usability concept, and we add the U to the acronym to make loud. So we want the data to not only be accurate, precise, and so on, but also to be usable and thus useful. Because if it's not usable, then no one will use it. If no one uses it, then we've wasted our money in producing it. Which means that we need to have consistent and easy to work with APIs. So here is a particular statement about APIs that I think captures the sentiment pretty well. When it comes to APIs, developers argue users. The same principles of user-centered design apply to the development and publication of APIs, such as simplicity, obviousness, fit for purpose, etc. E.g., we should be looking at our data not solely from the view of how precise is it and what research can it enable, or what preservation and description of objects can it enable, but how usable is it to actually do things with. So there is, of course, a trade-off between completeness and usability. So if we have 100% coverage of all of the information that an institution knows about any particular entity, that's likely an awful lot of information. And thus, while the publisher might want to enable all of that, the developer will quickly get lost. And hence we need to make some choices about both how to represent the data and what data to represent. So we're looking for somewhere in this target zone in green between usability and completeness. So as you add completeness, initially usability goes up because you need at least some knowledge in order to be useful. But then it sort of levels out and plateaus. We're looking to maximize the area under this curve. So you want as much completeness and as much usability as possible. So we think it's somewhere in here. It's not absolutely everything that we know. It's not nothing that we know. It should be maximally usable and maximally complete at the same time. So one of the things that we've done is to adopt JSON LD as our serialization, because that is one of the lingua francas of software development at the moment. If it changes in the future, then we'll change our format. So this is linked open usable data. As a human, you can read this and see what's going on. As a machine, this converts trivially using standardized libraries into RDF for the graph for processing and querying. So I'm going to walk through the translation of this object from the Getty into linked art. We'll hit almost all of these particular fields just as an example of how this can fit together to at least see how it works in practice. So first of all, at the data for humans levels, we need to know what sort of thing we're talking about. Is it an object, a person, a place, an activity? We then need some vocabulary terms, such as being able to classify those entities to be more specific for the domain. So, there's an Amphora, what's an accession number, and so on. And then we need to record that core identity, such as names, identifiers, and descriptions. So we start off with an entity, this brown guy in the middle, and it is a human-made object. So this is its class. We then give it a label, which is just a string, so that if all you get is, here is the URI, it's this type, and this is a label intended for developers to look at, you can at least understand what this URI is describing. So now we can add the object type. which is Amphora. And for this, we add, we use the AAT, move the defaulted one. So this in the CRM terms is a type or a concept. It has a label, Amphora, and it has a URI AAT 300148696. So this then adds this conceptual layer of vocabularies into the ontology layer. Okay, titles. Clearly, we need to be able to talk about titles of things. So in CRM, each title of an object is a unique name, and hence this particular name identifies this object. It could be different. There could be two different objects with the name Attic Black Figure Neck Amphora, but because this has its own URI, this name identifies this object. So now we have content, which is the actual string. We repeat the classification pattern to say that this is the primary title, so AAT 300404670, and again, this is a class. Type is again the class of the entity. In this case, it's a name. And folks who are familiar with CRM will say, there's no class name. Sanderson, what are you talking about? So in JSON LD and linked art, we can map from the more technical ontological properties and labels, such as E33, E41 linguistic appellation, to something a little bit more developer friendly, in this case, name. And that's why you do not see E22, human-made object, or P1 is identified by in these slides. Instead, we use the more developer-oriented casting of those properties and class names into something that's familiar to JSON developers. We can use that same pattern to have identifiers as well as titles. So the object number, in this case, an accession number, 86AE75. The object is identified by an identifier, but it shares exactly the same pattern of data as the name, in that it has a content, 86AE75, and it's classified as, in this case, an accession number rather than a title. Dimensions, again, follows the same sort of pattern. In this case, the property is referred to by to a description, which is a linguistic object. It's classified as a dimension statement. It has some content, which is just the string 38.7 space X space 25.7 space CM, etc., etc. Okay, so now we have the sort of core descriptive knowledge as strings available as data for humans to read. But hey, it sure would be nice if we could take that dimension statement and turn it into something that machines could process. So we could split this up into 38.7, 25.7, and the notion of centimeters. This is going from strings to comparable values into our next tier of accuracy. So CRM gives us some really useful ontological language in that there is a property dimension and a class dimension, and values which can be numeric. So the object has a dimension of 38.7. There's our first one. But now we need to know what unit and what type of dimension it is. So we use AAT, which has the notion of centimeters for the unit. So now we know it's 38.7 centimeters. And again, we go back to these types to say it is 38.7 centimeters high. We can, of course, do exactly the same thing for width, duration, any other dimension that we want. So now we're getting into linking together entities rather than just core descriptions of things. So there are people, there are places, and there are times. So we'll look at the production of the object. So the object was produced by a production, which has a class of production, and it was carried out by ULAN 5000291118, who is known as effector. If you were to dereference this URI, you would get a lot more information about effector, In beta testing at Getty at the moment, there is a linked Dart representation as well as the current more vocabulary focused representation. It took place at a place, TGN 7001393, which happens to be Athens, Greece, and the same. If you were to dereference that place, you would get more information about it. And it took place at a particular time span, which has a label of about 530 BC, and you would also express that as a name of the time span. It starts, or the earliest possible time is 540 BC, the end time would be 520 BC. So now we have this, we've sort of zoomed out, right, to the activity-centered pattern of the what happened, the activity, who did it, when they did it, where they did it, and what did it affect. In this case, it produced the object. So now we get into data for machines and linking across institutions. So here it's not good enough just to be on the web, to put a blob of JSON at a particular URL and then walk away. We want to be part of the web where we contribute data as a community that references other data on the web within the community. This lets us do shared cataloging because there's no need for everyone to describe everything. One of the really interesting things that Stephen brought up in the previous CRM discussion was around the documentation of the documentation. I think that's also something where we can work together because not everyone needs to fully document all of the patterns and vocabulary decisions. Instead, if we all make the same decisions, then we only need one set of metadata about what we decided to do about our processes. It also improves discovery because we have access to a lot more information about each of the entities than any one institution could possibly look after by itself. And this additional information and the connections between institutions give us better research results because we are more confident that this is something that is precise and valuable. So there's a couple of ways that this could be done. So the bars shows a visual work, which is a visual item in CRM terms, which represents a person, Theseus. So this is now outside of AAT and CRM and over to icon class. And icon class then has its own ontology and so forth. There's also about the concept of victory and armed conflict. Icon class 45A3, again, which is a type. So now that we've cataloged and described the visual content that the object shows, it happens that there is also a copy of this in the Louvre, which they have the accession number of F22. So instead of both organizations, the Getty and the Louvre, both having to fully describe their objects and then somehow link them together, instead the Louvre could simply say that it shows exactly the same visual work as the copy of the Amphora at the Getty. There's also another one in the British Museum. So even if they did all fully catalog the objects, at least if they had the same identities here, we'd be able to connect them together at the graph, at the web layer, to know that there are 3 copies rather than having to search through the thousands of museums to find them. So I think we are reasonably on time. So thank you for your attention. And in the next hour, Edward and I will sort of do that at less hurried pace and working through each of those particular patterns and ideas to see how this can really be done in a practical sense, and to, I would say, prove that this isn't a complicated, complex task. This is something that we can start to do today.